So let's see. So let's see if there is any person that remain. Okay, we are 9 numbers, so I think let's start and see how we are going to solve some of the problems. And then another time we'll try to see how we can go to solve other problems. So we have about 12 questions here. We want to see how to go about them. So the first one, they're all multiple choice questions. That is objective. So number one, we have, so I think you can see the question, right? Number one said, in liquids, all the particles A move randomly with unlimited space, B move randomly with limited space, and then C, if we scroll, you can see that C is vibrate at a fixed position, D vibrate randomly with unlimited space. So here we know this is the properties of solid. Solid, the liquid move freely, and the space are limited, so they are not unlimited. That means there is no ending. That means there is ending, so that answer should be B. So you see our answer here is B. So I hope you can see it. Hello? Okay, so the answer is B because it moves randomly with limited space. So the next question is the density of 5 liters of a substance in kilogram while having a mass this is that. So here it is a very easy. So for us to see it, we have the volume, which is 5 liters, which is 10 to the power of minus 3 meter cube. Then we have the mass, which is 5 kg. So therefore the density will be mass over volume, and the mass is 5 divided by this, which is 5 times 10 to the power of minus 3. 5 cancel 5, the minus go up, we have 10 to the power of 3, and that will give us 1000. So you can see the answer. If we scroll, you can see that the answer there is E. That is 1000. So 1000 is the answer. So this is how to go about question 2. That we have 5 liters, we have to convert it to meter cube by divide by 1000. We have the mass, then the density will be mass divided by volume, then 5 divided by 5 cancel, 10 to the power of minus 3 will go up, then we have 1000. So the answer is that. So this is how to do question number 2. So question, do you have question? So is there anybody that have a question to ask? So number 3 part. So number 3 part, we have to now look at number 3. In gases, so all this was also properties. In gases, the particles are closely packed, not freely to move, regularly packed. They are always very far apart. So they are this. So they are very far apart. So we can now select this as our answer because they are very far apart. Far apart. Because that's how this closely, that is for solid. When you talk of closely, that is you are after solid. So here the answer is D. So this is how we do D. Then the next question, question 4. So we have question 4. Question 4 is this. A substance has a relative density of 1.5. What is the mass of the substance in 30 cm cube of its volume? A, the answer is 45. B is 45 kg, 20 kg. One is in gram, one the other in kilogram. 20 gram, 20 kg, 38 gram, and the rest. So how do you go about it? So first of all, we know First of all, what we need to do is to find the density, and now we have a relative, because the volume is in cm cube, so our rho will be that relative density times the density of water, H2O, and the relative density is 1.5. The density of water in gram per cm cube is just 1. This will give us in gram per cm cube. So that will give us 1.5 gram per cm cube. Then we want to find the mass. The mass is going to be rho times volume, because density is mass over volume. Then the density there is 1.5 in gram per cm cube times the volume is 30. So if you multiply 1.5 times 30, you will left with 45 gram. So this is how we do it. So if you check the option, you can see that is A. So we have A. A is the answer, that is 45 gram. So this is the way to do it, because we are given volume in cm cube. That's why we don't need to convert it. So all you need to do is to use the density of water as 1 gram per cm cube instead of 1,000 kilogram per cm cube. So we now get the answer of 45 grams. So this is how to go about it. Then question 5, we have matter consists of tiny particles termed as what? Matter, atoms, ions, elements. So we know it's going to be particles, so that one is going to be atoms. All matters are made up of atoms. So because the element made up of atoms, the molecules themselves made up of atoms, so everything in matter is made up of atoms. So this is how we do from question 1 to 5. Matter consists of particles called atoms, then the substance, relative density. So this is how we go about it. So question, so is there anybody have question to ask? So let's see whether somebody have question to ask. So do you have question to ask? Hello? Hello? So are you hearing me? All of you? Okay, so this is how to go about it. So they are very important questions. So all these questions are very important questions. Like I said, it's going to be recorded. Then later, we upload it for you to watch it again. So there is no point for you to copy it. So this is the first set, 1 to 5. So this is how to go about. Some of them are those direct questions. Some of them are little calculations which you need to understand. You see some of the options, this is kilogram and this is gram. So that you have to be careful not to make mistakes in this. So that's why you have to be careful with the unit kilogram. This one is gram, this one is kilogram. You can likely make a mistake by not looking at the symbol. See, the answer is 45. Somebody may went up and said B because it didn't see the G. Without knowing that he has made a mistake. So the same thing, just like this, when you have 100, you have 1,000. You have to be careful the way you look at the options. 100, but the other one, which is 1,000. So this is how to go about them. Then let's see the next question. The next set of question now is this. So we have question 6. A substance is cut into several pieces as compared to the density of the original shape. The density of each piece will be what? So this is an interesting question. If you divide it into many smaller parts, then the density is not going to change because it's the same material that you make, no matter how small it is. Even if you break a sugar, no matter how tiny it is, it's still the same sugar you have. So that's why the density will not change. So the density will remain the same. So the answer is there is D. Because it's the same material that you are going to have. The density of that material remains constant. It does not matter the size. But the volume and the mass will give you a particular ratio. So because of that, and that is why the density will remain constant. The ratio will be constant. Okay? So that's how we do question number 6. Question number 7. Two different substances with density this are mixed together to form a mixture. What will be the total density of the mixture? To here we can see that rho 1 is 3,000 kilogram per meter cube, and rho 2 is 3,000 kilogram per meter cube. They want to find the total. So the density of the mixture is rho 1 volume F1 V1 plus V2 plus rho 2 V2 over V1 plus V2. So because you can see the question there is incomplete because we are not given the volume of each, or the mass is not given. So there is no way we are able to get the total density of the mixture because V1, V2 are not given, because this is the formula to calculate total density of a mixture. You see, if you add 3,000, 3,000, you see, you think it's 3,000. If you subtract rho 1 minus rho 2, you think the answer is 0. So that's why you have to be careful of not try to make that mistake of not just adding direct or subtracting. Because when you add, you see the answer is there, 6,000. So the correct answer is that the V1 and V2 are not given. So it's going to be none of the option. So none of the options. So you have to look. You don't need to rush and say, oh, because I'm giving it, I will just subtract. That's why when you subtract, you get 0. And when you add, you get 6,000. And when you leave one of them, is this. And that is those to make you to test your understanding. So that is the way to go about that one. That is question 8. That is question 7. So the answer is E. Then question 9. Oil float on water. Then the most accurate reason for this is what? Is oil is immiscible, does not dissolve in water, that it does not mix in water. B, oil is both less dense and immiscible to water. The oil is less dense than water, water is heavier than oil. The correct answer is this. While the oil does not mix, is 2 reasons. 1, it does not dissolve. So if it does not dissolve, it's 2 ways. It is either, why the noise, please? It's either the oil will be at the bottom or it will be at the top. While is it at the top, even though it cannot mix with the water, is because of it's less denser than water. So the answer is B. You see, the answer is B because 1 is lighter than water, is less dense, and since it does not mix with water, and that is the reason why it remains at the top. If it's heavier than water, then it will not mix, then it will go at the bottom. So we have B. So we have B as our correct answer. So you see, some people are making this noise. Zainab, there's some people are making noise like. Okay, so you see, I've solved question what? Question, which question is that? Question 8, the most accurate because the oil is lighter than water and it does not mix. And that's the reason why it's at the top, because it's lighter and it does not disappear because it does not mix with water. And that is the reason. So the answer is B. Okay. Then the question 9, the ability of the material to deform without breaking is called elasticity, plasticity, creep. Then we have viscosity, surface tension. So this is a very straightforward question. We know is what? Elasticity, right? The ability of material to deform without breaking, there is called what? So you see that answer is so the correct answer there is this one, which we have as what? as A. That is elasticity, the ability of material to deform. So, and that's why the answer there is A, elasticity. So that's how we do all these questions. You have to look at them very well. Plasticity is there, which has a different meaning from that. And that's how we do number this. Then we go to the last set of the question. We have the last set of the question. You see, so this is a little bit calculation, which we are going to see now. A spring this in diameter as original length this. The string is pulled by a force 200. If the length of the spring is 2 meters, use this information to answer question 10 to 12. Determine the stress in this produced. Now, first of all, we need to find the area, which is pi d square over 4. Pi is 3.142 times the diameter is 4. So we say 4 times 10 to the power of minus 3 because it's millimeter. All this square divide by 4. Then if you do that, you will get 1.3 times 10 to the power of minus 5 meters square. So therefore, our force is 200 Newton. So therefore, the stress is force over area, and the force is 200 over the area, which is 1.3 times 10 to the power of minus 5. When you divide, you have 16 times 10 to the power of 6 Newton per meter square. So if we check, I think that answer is A. It's clearly here, which is A. So this is how we go about it to try to what? Find the values. So find the area because they are given diameter in millimeter. So divide by 1000. Then we square it, divide by 4, multiply it with pi, we get the area. The force is given as 200. This is the force. This is the diameter. This is the new length. And this is the original length. So this is what we are given in the question. That's why we solve. So the answer for this is A. Then we have that of question 11. So under question 11, let's see how do we solve question 11. To solve question 11, what is the strain produced? So the strain is simple thing. Extension is length final minus length initial. The final length is 2.02. The initial one is 2. If you subtract, you have 0.02 meters. So now the strain is going to be extension over length. And that extension is 0.02. Original length is 2. Of course, this is L naught and this is E. The L naught there is 2. If you divide, you will get the answer of 0.01. Again, you can see they look similar. You see, if care is not taken, you may end up making mistake 0.1, 0.01, 0.25, this and this. So you can see the answer there is C. Clearly is C, which is 0.01. So you might think this is the answer because without seeing it. And that is what sometimes you made a mistake. So try to know that this is how to calculate the strain. Then the last one, we have to calculate the Young modulus. So that is Y. Y is nothing but the stress over the strain. It's very straightforward. The stress we have now is 16, which is this. So we have 16 times 10 to the power of 6 divided by the strain, which is this, 0.01. If we divide, we now have 16 times 10 to the power of 6 times 10 to the power of 2. That is 16 times 10 to the power of 8. Convert this one to standard form. You have 1.6 times 10 to the power of 1 times 10 to the power of 8. This gives you 1.6 times 10 to the power of 9 Newton per meter square. So that answer is see it here is C. The answer is C. 1.6 to the power of what? To the power of 9. So this is what we have. So let's see whether question you have a question to ask. Do you have a question to ask? Okay, like somebody want to ask question. Ismail Zainab, which question do you have? Ismail Zainab, do you have a question? Hello? Hello? So are you all there? Hello? You have raised up your hand. Do you have a question to ask? What's the question? That is if we are going to find the strain, there is no need to convert it because they will cancel at the end. Because they will cancel at the end because it depends if you are looking for the strain, because the strain have no unit. End of the day, whatever unit you have, they will cancel. So no need to convert it because if you are finding the strain, it will cancel out the unit. So it has no unit. So it's only the stress that the area should be converted. That's why we have it in Newton per meter square. So this is how to go about them, which you have solved. That's why it is there. See, that's why it's now recorded. I'm going to upload it so that you can see it there. So that you have time to go over the questions and see and cross-check and what you have. So there are many other ones that will follow. But this one is just a set. That's why you have so many other ones that will follow till you enter into the fluid. So that you're able to know the meaning of density, while substances float, why do they float, the mix and the rest. And that is so far what we have done. So we're able to start from this. Then we end at at this one. So this is what we have. So now I think we are going to try to stop here. And then we'll get another time to meet to finish the second part, which will be many, and then the last part, which will now end under the fluid. So this is just the first part first we are doing. It's not much, but the second one will be much, which you will see so many interesting questions. So that's why they're very important questions for you to try to know. That's why. So I think we can end it from here.